Okay, so I'd like you to take a little bit of time and just have a read of this information. We've already talked about a cone previously. Okay, a cone is a solid shape with a circular base and a curved surface, and that also has an apex, in other words, the top point. However, a cone is not a pyramid because its base is not a polygon. Remembering that a polygon is a shape that has straight edges, like a cylinder. A cylinder is not a prism because it doesn't have the straight edges. The other thing you need to know is the slant height of a pyramid or cone is the height from the apex to the base. Okay, so the slant height in this case is on the outside. So these bits here. Okay. Okay, let's go on. Okay, so let's start looking at solving this. Again, sit back. What do you notice? I notice in this shape that I have a base, in this case a square base that is 14 by 14. I also notice that I have 4 triangular sides. I do have a slant height, which is 20. So there's my height and there's my base of 14. So in this case, I have a triangle with a height of 20 and a base of 14, and there are 4 of them. So when I go to do the surface area, I'm literally dealing with surface area is 4 by triangles. So there's 4 triangles plus a square. Because remember, surface area is adding up all of the faces together. So the 4 triangles, we know the formula is half times height times base. Okay, and there happen to be 4 of them. And I know the base of the square is 14 by 14. Now, once again, you can use a bit of your maths here. Depends how you want to go. You can go half of 20, which is 10 times 14 times 4, or you can halve the 4 first, which is 2. Doesn't matter. And I end up with an answer of 756 square centimetres. Now, with the next one, this case they've given you a perpendicular height, not the slant height. So once again, you're going to have to use a bit of Pythagoras to work that out. Because if you have to visualize it on the center. So if you can imagine this triangle here, there's actually a slant height there that forms with that right angle triangle. So if I can sort of use the highlighter pen, okay, that is a right angle triangle, and the blue line I'm about to draw is the slant height that is on the outside of the triangle. So first of all, I need to use Pythagoras to work that out. Now notice when I was working out the slant height that I've actually gone 20 squared plus 15 squared. That 30 is for the whole of the outside of the square or the base. Okay, so the inside we only need 15, which is half of it from the centre to the outside. So now that I've got my L, which is 25, because I've done the 20 squared plus 15 squared, square root it, I can now start working out my 4 triangles and my base. Okay, so I've added all that up together and I end up with 2,400 square centimetres. Just be aware that at the moment we've got some pretty easy questions in that all 4 triangles are the same dimensions. That won't happen in all examples, so don't just get into a habit of thinking once you do one, you can times by 4 and all is good. Okay, and here's a lovely example where we have several triangles that are different dimensions, and we don't necessarily have the slant height of all of them. So again, sit back and just sort of have a look and see what you've got. I can work out the surface area of each of them. If I have a little look at my triangle, I have a triangle obviously here. I have another triangle here. Now this one is a right angle triangle, the blue one there. And there is another right angle triangle at the back there. Now the fact that they're right angles is handy because that means they already have a base and a height, which means we can actually work out the area of that particular triangle. Other things I notice is I've got double lines here, so that means this is going to be equal to 12. So I've actually got a triangle on the base, which is isosceles, which is 12 by 12 by 10. I have another isosceles triangle up the top here, which is 20 by 20 by 10. You may even find it easier in some cases to draw the triangles out. So I've got a 20, a 20 and a 10. That's equivalent to my red one here. Okay, on the ground, or on the base I should say, okay, I have a 12 by 12 by 10. I'm going to refer to that one as the yellow one. Okay, that was sort of this one down here. I have the green one, which is 12 along here. It is a right angle and I don't have a height, but I do have a sloping, or hypotenuse I should say in this case, and that is equivalent to my green. And then I've got the blue one left. Now with the blue one, again it's 20 by 12. Oops, sorry, I changed it to blue. There's my blue. And just so we've got an idea again of what's happening here, it's actually equivalent to this one here. Okay, so you can see the 20 and the 12 and the right angle there. So every single one of these is going to need something done to it. This particular one we're going to need to work out the height. Okay, same with this one, we need to work out the height. The reason I've gone up between the two 12s is because it is isosceles, and I know that if I draw a line straight up the middle and hit the base at right angles, then it will be even. And this one over here, I need to find that for the height divided by the height times base, and over here I need to find out the y. So in this particular question, I'm also going to label each of these A, B, C and D, just so we can keep some order about our working. Because remember, I'm always emphasising to you that the marker must be able to follow your work. Okay, so with A, I'm going to find out the height. So I'm just going to do some working first. Okay, so I've just done two of them so far, where I found the height first. And then once I've found the height, I've been able to find the area of the two different triangles, in this case the red triangle and the yellow triangle. Okay, so lucky for us with the next one, they've both got the same dimensions. So when I go to find x and y, which I'm actually now going to change both to x, okay, I can do the same thing. So I've got x squared equals the hypotenuse, which is 20 squared, minus one of the short sides, which is 20 squared. And of course that gives me x equals the square root of 256. Square root 256, and I get x equals 16. I can now use that 16 as the height to work out the area, which is going to be half times the 16 times the base of 12. But of course we have got two of them. So the half and the 2 now cancel each other out, which is handy. So 16 times 12 is 192. And of course I'm dealing with square metres. Now, just because I haven't done it yet, I need to make sure that I put C and D up here in my working. So again, the marker knows that they're both the same thing. And now I can start working at the total surface area. So the total surface area, and again, it's important to show the marker that you understand what you're doing, is A plus B plus C plus D. And I'm going to add all those together. And the answer comes to 343.36 metres, square metres. So a complicated question in that it was long and involved quite a few bits, but once again, not hard, just painfully long.